Yes. Let me try this one. So just to show you something, right? So there's a loop here. There's a loop. This whole thing is a loop. There's a loop. There's a loop. So I have one, two, three, four, five loops. I will have a node here like one, two, three, four, five, six, seven. Whew. Yeah. Loop analysis will be, hey, look at that. Yeah. So loop analysis will be easy, I think, to use for this one here. No, that'll be longer. Yeah, but anyway, so let's just run through this one quickly. I wouldn't do the whole thing, 'cause I think I'll catch it by now, but I wanna see if it have a super node in it. So I could see the occurrence of it. So there you go. So you know where ground is. You don't know where ground is, so we can label this as ground, right? Because they never told us where ground is. Right? But um if you're doing it in so exam, um let me see. He will normally not give you a ground. So what I want you all to do just to be safe is if he doesn't give you a ground, just treat it as a node and just give it a name just to be safe, right? Just to be safe. Because sometimes it does be kind of weird. So just name that VA just to be safe, right? It's the same calculations. So there's a node here, there's a node. All this is a node. Wow. Well, let's have a node. Here I have a node. Here I have a node. Let's have a node. Here I have a node. And I think that's all like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Like label them. So like VA, VB, VC, VD, VE, VF. Yeah, so I label my nodes like normal. As I said, just to be safe in Albert's exam, just don't just assume a zero, just treat it like a normal node. Alright, so there you go. The second thing I'm looking for is supernodes. Because notice there are real batteries in this question here, right? So nothing, none of the batteries started from zero. You notice that? These two, not the answer, know where it is. So in this question here, this is a super node, and this formula super, just like we did before, is the same thing. You have to literally include everything, the n and the voltage source itself. So this one here could be a super node. Ooh, that's a big node. Yeah, how? So the node before, node the voltage source, and the node after. Just like before, it's just looking weird in this one. All right, and the other super node would be this. Yeah, node before, battery, node after. You will notice that the node always ends at either a current source or a resistor. If you notice, resistor, current source. Current source, resistor, 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 resistor. The supernode, the endpoints will always stop at a resistor, right? So that is all. So we have our two. So we can name this VS1, and we can name this green one here VS2. All right, so just like before, I'm not gonna do this because it's the same thing. That is why I saw me did like 3 questions in the tutorial because it's the same thing he doing. You just don't know what to look out for. So in this question here, what unknown nodes we have? So we have two super nodes. We have VS1, we have VS2, we have the link for VS1, and we have the link for VS2. Yeah, come on, but each super node have a link equation, right? So that is 2, right? 4. So that done there, and this whole thing done there. We have VB, we don't know. What else we don't know VA, so we have to get the link the equation, sorry, for VA. Right? And that is all the equations you will need for this circuit here. Yeah? Because you have a super node here, get the equation in the endpoints like we did before, and look at our current source. And you know the thing in this branch here will be two positive, two could go in the same direction. If you are going inside, if you're going into the node, that'll be -2. All right, and you do a link equation for it. So if I do not, for example, it'll be VF minus 12 is equal to VE, or VE plus 12 is equal to VF. It don't matter once your polarity is correct. All right, this one here, look at current source. Look at that. I look at that. I love current sources. All right. If you're doing a supernode equation for this here, if I start with VC, I think VC plus 6 going from minus, so positive is equal to VD, or VD Subtract 6, plus or minus equal to VC. Yeah, that's the same thing. And obviously for VB, normal, easy thing. You assume it going out, or you assume it going in. Hey, look at that. Current source, so you know whatever happening. And that one is either 4 milliamp or minus 4, depending on if you assume it going in or out. Yeah, this one, is where coming from, minus where going VA, VB minus VA and 2. This one, same thing. So, and this is a super node, right? So it'll be VB minus VS2 over 2K. Yeah, come on, we're treating it supernova, that different name, right? Because it's like a combination of all this stuff inside of it. So be careful, right? And yeah, that was our question right there. Real simple. All right, we didn't do loops, so I'm not going to stress a little. All right, same thing for this one here. I think this will be the last question. All right, the rest, I'll give all of them to try. So same steps. I repeat any steps for a reason. So I show all here how to label the notes. I show all here how to look out for the supernode. Make sure I look out for that. I show all you how to deal with the dependent sources. Just be careful with them. All right. I show all you how to with the ground, how to calculate. I show all you the common mistake, which is why I did with calculating the nodal equation for a node they already know the voltage for. Just wasting time. All right. And for every supernode, you have a link equation for it. Every dependent source it have an equation for it because you have to tell them, okay, what it depends on. What is VA or what is I1, whatever it is. They will tell you where in the circuit it depends on, and you just have to derive the equation for it. The trick is just note the polarities of stuff. Okay, will help you to know if you're looking for positive answer or negative answer. Like if it's a voltage rise, you're expecting a positive. If it's a voltage drop, you're expecting it to be negative. Same thing for currents when you do loop analysis. See, same. All right, so let's try this one. Let me try this one. Same thing. There's the last one I'm going to show you. So the first thing is, as I said, I would think kind of where to just assume where the ground is. You never give it. So just treat it like a normal node, right? So I say like draw, I feel like use this color, I use a different color. I got so much color in space. I try this one. Ooh, that hard to see, right? Let me try different one. I try this one. All right. Good. All right, there you go. So you draw that line node. What else have a node? You have a node here. You have a node up here. What else you have a node? You have a node here. And we have this node in the middle. Right? So just to recap, if I had to draw the loops in this one, there's a loop here, right? There's a loop here. There's a loop here. There's a loop here. Four. So we have one, two, three, four loops, and you have one, two, three, four, five nodes. So the better one to use in this one will have been loop analysis. Yeah, I like doing that to show it. So they could see which one is the better. But at the end of the day, you're just gonna do what to say. So that's a show. Yeah. That's for fun idea. So there you go. So we label our nodes, right? So like label this VA, VB, VC. Why is such back red? VD and VE. Yeah, that's correct. A, B, C, D, E. Yeah, everything labeled. All right. Third thing, we need to look for supernodes. Do we have two unknown nodes in between our voltage source? Yes, if we could look it up in here and look it up in here. But in this question here, right, it makes no sense having a supernode intersect with our next supernode, right? You will notice, remember I told you, you could have something like this. You could have a battery and it could have a node at the end. You could have something looking like that, right? So you just treat the whole thing as a super node, right? So in this question here, this will be my endpoint for one of my node, the super nodes, and this will be the next endpoint. It can make no sense doing this. I'm not sure what logically makes sense, right? You will do like, all right, there's a super node here, so you'll do this. And then you'll be like the next super node, you'll do this. Yeah, that makes sense, right? Yeah, that is logically what you do. But it makes no sense. Because you could just treat the entire thing as just one super. Okay, how about intersection? Remember Venn diagrams? You get super now. Yeah, Venn diagrams, the intersection, you could just treat the whole thing as one link. Yeah, so anytime you see that, Anytime you see supernodes intersecting and thing, just treat the whole thing as one supernode. So if I draw it for this one here, it will look like this. So the whole thing here, pow pow, and point, and point, and point, and point, and point, pow. And I'll treat that whole thing as a V super one. Right? So that whole thing there is just a supernode. Right? Okay, just basically a clump of batteries. Come on, a node is a voltage, right? So you can treat it like a clump of batteries. Nice, so we have a supernode. So in this question here, so I'm not doing it because it's the same thing. If you assume the current going out, 'cause like how I custom doing it, I'll do one. Might not have enough space, but I'll do one. So if I'm doing it for VS1, right? So we have 1, 2, 3, 4, 5, 6 leaving. So we have 6 mini equations have to equal to 0. Do not forget that because you will lose all your marks. All right. So literally lose all, not only for that equation, even all, because it's a system of equations. So be switched on when you're doing this. It's very simple, but make sure you know what you do. So now we start with 1. Same thing. Where you coming from? VB. So you're coming from VS. While name is super, we're coming from V, right? So we're coming from minus, we're going, what's the plus I doing? So VS1, sorry, minus we're going, so we're going to VE divided by 1K. Right, that makes sense. We're coming from minus, we're going. So I'll do this one here, so you do this one at the bottom. So it'll be we're coming from VS1 minus we're going, which is VA, divided by 2K. So I did this one. I go to 3. So hey, look at that, look at current source. Would you look at that? Is it in the same direction as what I assume? Yes, it is. So this here going to just be plus 4 milliamps. So that's done. Moving on. Hey, look at current source. Is it the same direction that I assume? Yes, it is. So this would have going to be plus 2 milliamps. So moving on. Go down to this one here. Oh, not a current source. We do the normal thing. So it'll be plus we are coming from minus we are going. So we'll be going to VA all divided by the resistance between them, which is 1K. So that done. Up here now, same thing. We're coming from minus we're going to VE divided by 2K. And is equal to 0. Yes, nice. Make sure I read that. Nice. Write the equation for it. Nice. So now we ain't done yet. We have to write the link equation for the supernode. So the link equation for the supernode would just be, so it don't matter where I start. So I'm gonna start with VD. So it could be VD. So there's our voltage rise. So it could be plus, what is 6? Plus 6, then plus VC. Then there's our voltage drop, minus 4, and that is equal to the end node, which is VB. Yeah, VB here. So if I write it in a nicer way, it could be VD plus VC minus VB, and 6 minus 4 is what? 2. I calculate 2 again, negative 2. Yeah, and that is it. So it have other nodes. It have VE, but oh gosh, I really gonna put me through that. If I assume everything going out, there's going to be negative 2 here because it's going against what I assume. And this here, so it will be VE minus VS1 divided by 1K. This here going to be minus 2. This one here, we're coming from VE minus we're going, which are going to the supernode. So it could be VE minus VS1 divided by 2K, and all of that equal to 0, and you're done. VA, same thing. I assume everything going out. So this here gonna be going against. So it could be minus 4 million. Okay, going against what I assume. Right? This one here, same thing. We're coming from VA minus we're going, which is to the supernode. So we VA subtract VS1 divided by the resistance between them. This here gonna be minus 4. So plus. So yeah, plus minus 4 will be minus 4. Minus 4. This one here could be we're coming from minus we're going, which is to the supernode. So VA minus VS1 divided by 2K, and all of that is equal to 0. And the same thing for VE. So we have VA, we have VA, we have the supernode, and we have the supernode link equation. It have no dependent sources here, so I don't need to write the equation for it, and you're done. Stop right there. All right, nice, you're done. Stick on there. All right, so let me see if I have any more. I think I show everything I need to know. Yeah, look at this here. So let's see, it have a dependent source in it. So if I'm doing it, I'm doing it real quick. I'm gonna show you how quick I do this. So if I'm doing it here, my the steps already in my brain. Don't get confused with this. It's just telling you the direction that IX going in. So it's not a diode. It's just a symbol when you see that's telling you the direction of the current. All right, look at plus. You'll be like, oh, what's that? It's just telling you the direction. It's not a diode. So it'll be like, yeah, the subtract 0.7. It doesn't overlap. You're not gonna bring a diode. This is not 1011. All right. So there you go. So power. You get my ground, which is good. So that means this whole node here is 0. We shoot in. So there's 0, 0, 0, 0, 0. Draw my node. So this here is our node here, right? We have a node here. Where else we have a node? We have a node here. We have a node where? There's a couple nodes. Yeah, that's all, yeah. I think that's all there. Everything covered. Yeah, everything covered. All right. Third thing, I need to look for supernodes. Same thing. Do I have two unknown nodes at the ends of a battery? Yes, I do. Okay, right here. So what do? I don't have it like before where I have a next battery at the end of it here. If it had here, you'll have combine all of this as to one node. You don't need to do that. This one is a nice, easy supernode. So what you do? Run through your steps like normal. You group everything here as one supernode. Let me name it V N because I fed up with V as well. All right. So yeah, V N. Let me go. All right. So that is supernode. That that done. We already handle the scene there. Let's label the rest. So we can name this VA. Well, we gotta label this here because we didn't know the voltage for it. And we can label this here VB, right? Anything we didn't label, well, okay, this is VB, just to make sure that inside the node we have nodes. Nice. We have everything good, everything labeled, everything nice. We have a dependent source here. All right. This dependent source depends on IX, actually, yeah, IX. All right. So if I'm looking at the circuit, I'll show you after, right? But this circuit actually easier than it looks because this here is 0. So I know the voltage at this node here. But anyway, so this is IX. Look IX up here. So basically what I'm asking you for is they want to know what the current here is. The current here. Yeah. So if I want the current here, think about it, right? The current IX is the current that going through this resistor here. Yeah, because IX will start here. It will go through here to end up here, then go through nothing else, right? So if I use a nodal analysis, right, the normal thing I'll do it is VE. So the current going this, yeah? So if I do the drop in between it, so think about it, VB gonna be less, right? So VB, F for VB here. So as I voltage drop. Why? Because I'm going to try this stuff. You expect VB to be less than VE because you're going to use up energy, right? So the polarities we choose, how they make sense. It can't be VA subtract VB. Why? Because VA will have be more than VB and you like a positive voltage, which just makes sense. Because you can't get a positive voltage up across a resistor. Yeah, that's why I say polarities will help you out. Just think about what happening. When you go try resistor be negative. So therefore this here will be VB subtract VA. That makes sense. Because in this case, VB will be less than VA and I expect a negative voltage drop. Yeah? So divided by 10. And that here will be IX. That will be the link equation for IX if you have to do it. Yeah, because the wanted I, you go I, right? The I is here. I know I is equal to, oops, what? Oh, I rotated. Wow. Anyway, so we know I is equal to VRR, which is our nodal equation. So basically, you're just looking for the nodal equation in between these two. So VB subtract VA divided by the 10 ohm, you'll like get the current going through here, which is IX. Yeah? We just don't know what you're doing here. All right, back to what I was saying before, this question actually easier because we know this is a dependent voltage source, right? So that means we know what the voltage is. Everything's set. This is 0. So we know the voltage of this. So this is not a supernode because for it to be a supernode, I need two unknown voltages on both sides. But since I know this is 0, therefore this going to rise. So 0 plus 5x, we have 5ix here. So this whole node is 5i. So I actually know the voltage of that node. Yeah, which will actually additionally simplify the question. Yeah, so the only nodes I really don't know the voltage for will be VA, and well, obviously the supernode, which is will include the actual equation for it, and the supernode equation, and they have the VA and the link equation for IX because they have a dependent source. So you can have how much equations? One equation for the supernode, and next equation for the link equation for the supernode. You have an equation for VA because you don't know the voltage for VA, and then you have an equation for the dependent source IX. So that what 4 equations? Yeah. Mm-hmm. And I have to do that. I don't have to do it again. Because it's actually the same thing you do. Assuming going out, coming from minus where you're going, divided by the resistance between them. The supernode, it don't matter where you're going, just add up the polarities correctly. And the sum of all of them will equal to the last node. And you can rearrange it to make it look nicer and cuter. And you chop down. Alright? So I'm just go. So and that is it. I mean I can stop the class there, I already showed everything I need to know. I'll take that time the rest of questions for itself. Alright, so with that said, I don't need to do anything else. So I'll stop enough for questions. So anyone has any questions, I need to go over anything I did. You're all good. Because right now you'll have time the rest of questions using nodal analysis to break it down into the equations. Because y'all have all the skills and tools that you need to know. Any question, anything you want me to go over, you need me to do our next question, anything, or you're good with Nodal? And surely everything you need to know, surely how to get the equations, how to deal with the supernodes, how to deal with a supernode and a next supernode, they link it together. And surely the dependent sources, how to look for wherever it is, know your polarities. That is all you need to know. Now you can just go look at a question. Remember, for if you don't give you a ground, just book it like a normal node. Yeah, just to make sure. Because you never gave you what ground is. So you don't actually know what the voltage is. Alright? So with that said, that is the end of class. So I'll stop and if I have any questions. Then once, went twice, and that's sold. Alright, so there is no question. So I assume either they just out of it or they just understand what I show earlier, or they're good. All right, so I don't need to show all there any more circuits. All the circuit will always have a battery, a current source, wire, resistor. It's DC analysis. And that's why it does do the questions. All right, so let me see. Yeah, bro. Right, so that is it. Like at that time, there are some questions. Or like attempt the questions in the notes I send you all. So they will appreciate what then. And look at that time, this rest. It's really easy now. Or you know to mash up this now, VX. Now dependent. So see the check and see if you're going to get look at that. If you're looking at it here, if you assume this to be 0, or even if you assume it to be anything else, this whole thing here will get a super. You can just look at a circuit now and just be like, "Hey, there's a super." So all this here, pow, 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 pow. There's assuming if you didn't know what if you didn't give you a ground, all that here will be a super. Will just be a combination. Yeah, but if he gave you what ground is here, you would have known. If he had gave you what ground is, that would actually made the question easier. Because watch it, right? If he had gave you a ground, that means that this node here will have be 0. So watch it. So if this node here is 0, that means that this battery here going from rising up. So that means the node here will have be 0 plus 1. Remember, the sum of the voltages, sum of the nodes. So this here will be 1. And now because that is 1 here, there's our next battery. So now it rising up again. So now I know what the voltage of this is here. So it could just be 1 plus 6 Vx. Yeah, and that is if he had tell you what ground is. But if he doesn't, this here, giving it away. That's how I know the ground, because it's a rise. So it's rising from 0. So you can just pay ground there and go ahead. Right? So if you had given this, I made the whole thing easier. You don't need to do the supernode for this. Okay, you will know everything rising up. 0 plus that give you 1. 1 plus this battery will give you 1 plus 6 Vx. If I need to get Vx is our voltage, so it's a rise. So think about it as a rise, right? So expecting a positive value. So if I label this here VA and I ground, so it will be VA subtract 0 on 600. And I'll have the link equation for Vx. And you'll continue your rest. You don't know the voltage at this node. You do your normal thing. Well, you know, if you know, well, you can know these already. You calculate this one here, you don't know, and you go ahead. Current source, you know how to do with that. Yeah, you can mash up all the other questions now, but you literally have no question now that you cannot do using Nodal. Well, actually, no equation you can break down to get the resistor values. All right? And that is it. That is the truth. Don't matter what kind of madness you play any question of. You use that boss now. All is bosses now. Once you practice and do it. All right, so you all could try questions, send me pictures, I'll go through it, and it's good. Once you obey the steps I show you and the polarity is correct, you could. Just pay attention to your mistakes and make it equal to 0. All right, so let me see. I saw a comment. Yeah, I want it to render. I'll send you a recording. All right, so let go. So if that is all, if no